Okay, so the probability distribution of a discrete random variable is a list of probabilities associated with each of its possible values. And you can see that's described again on page 187 of the textbook. Alright, so I've drawn the table here for some random variable x. It has three possible outcomes, 0, 1 and 2. And the probability for each of those outcomes is given in the table. So the probability that x is equal to 0 is a quarter, that x is equal to 1 is a half, and that x is equal to 2 is a quarter. Now you'll note those probabilities all add up to 1, but we'll come back to that and talk more about that soon. Now we can represent this probability distribution in a table or in a graph. Column graph, as I've shown on the right hand side here. Okay, now we're going to look at what makes a valid probability distribution. Okay, so each of the probabilities associated with each outcome has to be a valid probability. So it must be a number between 0 and 1. So each probability has to be a valid probability. And secondly, all the probabilities need to add up to 1, because everything that's possible to happen must be accounted for in the probability distribution. So that is to say that the sum of all of the probabilities must equal 1. Alright, we're going to have a look at example 2 now on page 188. Alright, so in this they've got a magazine store and they've recorded the number of magazines purchased by customers in 1 week. 23% purchased 1 magazine, 35% purchased 2, 21% purchased 3, 13% purchased 4 and 5% purchased 5. So we're going to let X be the number of magazines sold to a randomly selected customer. So we want to state the probability values of X. Alright, so that gives us the following probability distribution. Note that there isn't an outcome for 0, so every customer who came into the shop actually bought something. 23% bought 1, so that gives a probability of 0.23, because we need to convert a percentage to a valid probability, which, as we know, is a number between 0 and 1. Okay. Alright, now we can represent that probability distribution graphically with a column graph. Let's just fix that up. So probability on the y-axis and our outcomes down there on the x-axis. Alright, so we want the mode and the median for this distribution. Well, the mode is easy. The mode is the one with the highest probability. So the mode is equal to 2. Now the median, we need to work out what's called the cumulative probability. So we're going to start at 1 and move our way up from 1 to 2 to 3 to 4, and we're going to add the probabilities as we go. And when we get to 0.5, then that outcome, or when we pass 0.5, that's the median. So we've got, starting at 1.23, we add 0.38 to that, and we've already passed 0.5. We've got 0.61. So going up here, we see that the 1 itself hadn't reached 0.5, but by the time we get to 2, we've exceeded 0.5. So the median is going to be 2. Alright, example 3 on page 188, we need to show that px equals x squared plus 1 over 34 generates a valid probability distribution for the values of x from 1 to 4, 1, 2, 3 and 4. So what we need to do is generate the probabilities for x equals 1, 2, 3 and 4. Alright, so we've generated each of the probabilities. P1, substituting 1 into that expression gives us 2 over 34. P2 is 5 over 34. If x is 3, we get 10 over 34, and if x is 4, we get 17 over 34. Now, each of those values is a number between 0 and 1, so each of them is a valid probability. So it's satisfied the first criteria for a valid probability distribution. That is that each of the probabilities are between 0 and 1. And then adding up all of those probabilities, we get the sum is 1. So each of the outcomes, or the probability for the outcome, is a valid probability, and the total is 1. So this, in fact, is a valid probability distribution. Alright, so what are we going to do now? Well, let's have a look at exercise 7b. And work your way through those exercises and see how we go.